So good morning. My name is Christine Richards, and I'm the research director here at Zpryme. We're thrilled to have you all here this morning for a session on IP, capital, and new energy business models. It's been really exciting to attend the conference and see all the different conversations that are out there. You know, all the new ideas, the new technologies, young companies that are really looking to grow and be a part of the energy industry. And we have a panel of experts here today to talk about some of those critical things around funding. How do we start to develop some of these new technologies and really bring them to the industry? So I'm going to do some quick introductions here with name, title, and company, and then we'll have each panelist kick off by talking about their organization and the role that they play in providing some of this funding. So right here we have Jamey Seeley, who is the Executive VP, General Counsel, and Corporate Secretary for ION Geophysical Corporation. Thanks for joining us. We also have Brewster McCracken, who is Pecan Street CEO. We have Michael Contreras, who has a very long title, and I will get through it. The American Association for Advancement of Science, Science and Technology Policy Fellow with the U.S. Department of Energy. And we also have Jonathan Blackburn, who is the CEO of Texas Pace Authority. So if each of you want to start out and just give us a quick summary of your company and how you're involved in this space, that'd be great.
Sure. So I'm Jamey Seeley. I work with ION Geophysical. ION is basically, at its essence, an oil and gas technology firm. We provide a lot of offshore high-tech services geared mostly for oil and gas companies. We do some manufacture and a lot of R&D, and we own a lot of patents. So that's what I'm doing right now. And I think a big part of why you guys asked me to participate is because I also just recently left NRG, working on a lot of their alternative energy projects, including clean coal, nuclear, solar. So I've got this weird, sort of crossover right now. So glad to try to talk to both as my alternative energy knowledge ages.
Excellent. Thank you, Jamey. And Brewster?
Yeah, so I'm Brewster McCracken, the CEO of Pecan Street. We are a research institute that is based at the University of Texas, and we're founded by UT but spun out as an independent research institute. So we do consumer research in, I think it's about 10 states now. We operate the world's largest research database on customer energy use, and I think we are probably about the third largest manager of customer energy use in the state of Texas each day. So it's we do data and customer research and really find out what people like and respond to, so that universities and companies have the best possible information and access to people.
Excellent. And Michael?
Yeah, Michael Contreras, AAAS fellow, but probably what's more relevant for this panel is I help run a technology accelerator-like program in the Department of Energy, where we back solar energy software startups. So it's an interesting mashup. It's kind of a confluence of a lot of major trends going on in the government. One of those being open data, how to monetize that data, how to leverage it. Another one is the increase in prizes and challenges across the government. So we kind of use prizes and challenges, open data, and then finally the last piece is soft costs affecting the solar industry. Right now, the major concern with the solar industry is not so much in the hardware arena. Those costs have come down dramatically. A majority of the cost stack up is in these regions of the soft cost areas. There's a variety of segments that we look at. I'd be happy to get into that later. But basically, we feel that software data and automation can drive down that cost, thus making it more easy to deploy solar. So that's the mission of the Sunshot Initiative, which drives the office that I work in at the Department of Energy.
Great, thank you. And Jonathan?
Yeah, Jonathan Blackburn with the Texas Pace Authority. I'm pretty new to Austin. Spent the past few years in the UK working for a venture fund that was commercializing technology out of the University of Cambridge. Recently moved to Austin, and I run the what hopefully will eventually be the statewide administrator of property assessed clean energy programs here in Texas. On Tuesday, Travis County became the first county in Texas to institute a PACE program. And my organization will be running that on their behalf and also looking to expand around the state.
So a lot of great perspectives here. I mean, all the way from oil and gas to solar, customer engagement. I mean, that's great. So the first area we wanted to get into was, what areas within energy are really exciting to you right now? Where do you see a lot of opportunity for growth and a lot of opportunity for change? Jamey, you want to?
Yeah, so I'll straddle both areas here and kind of take it by sector in rapid fire. And I think if you start with the nuclear sector, there's not a whole lot that goes on in that area. It's one of the slower ones, I think. Mm-hmm. But there is some really interesting tech with small modular reactors that I think is fascinating and has some really great potential. I think we're probably going to see that really mature and grow up internationally versus the U.S., mostly because of the U.S. regulatory regime not necessarily being well suited for that type of product, but it is a product that has a really great potential internationally. I think if you move to the solar area, I think the most interesting thing in solar right now is really some of the areas that Michael's group is actually working on, and where you're probably more the expert, so I'll let you talk to it in more detail. But I think we had this interesting time in solar where we were very focused on how do we squeeze cost out of the financing? How do we squeeze cost out of construction? How do we squeeze it out of basically every area in the value chain? And I think we're now at a point where the additional marginal returns from doing that are just not very good. So now you have to start to think beyond that and start thinking about how do you take solar and make it more suitable to demand response, to coming up with predictability models, to pairing it with advanced inverters and other technologies to really sort of take it to that next level, especially distributed storage, and bring it along in its technological evolution. And then to jump back into the oil and gas, my sort of present side, I think we're in a really interesting time in this sector. So it's probably the most exciting sector to me. The great thing about high oil prices is you have this great opportunity for new technology. You come up with great new ideas, and I think to a large extent you can say the whole shale boom is sort of born out of this opportunity that was created to go and get more costly hydrocarbons through new technology. So I think actually a reverse opportunity happens when you enter a market like we are now. So in a market where you drop down to $40 or $50 oil, I think you now have opportunities to take great new technology that's been created and now make it more efficient. And there's sort of no better driver to efficiency than necessity. And the one thing that market environment does create is it creates great necessity. So I think we actually are on a nice precipice of a lot of interesting technology innovations, and a lot of people will be very interested in investing in them, given the necessity and the market need for it. So I'll stop there for now, because I know you guys have a lot of other stuff.
Yeah, well, so from our perspective of working with consumers and measuring not just what they say, but actually what they do, so we're seeing some interesting things happening. I'd say that first off, as a little kind of context setting, the consumers don't sit there and act as profit maximizing rational actors. They buy leather upholstery in their cars and granite countertops for their kitchen, and there's no return on an investment of a granite countertop, maybe a little bit. But in other words, people buy things because of for a variety of reasons that are not financially oriented, and so sometimes consumers at some point. Some innovation will kind of click along, and then it'll hit this inflection point. It's in the S curve of diffusion of innovation analysis. When it hits about 10 to 15% of the market, it suddenly goes to 60% really fast. And so that's what happened with mobile phones. First mobile phone was $3,000. You had to charge it for 10 hours to get 30 minutes of talk time. It was intended for rich businessmen. This was 1983. It took 10 years from the first creation of a mobile phone by Motorola in '73 for the first mobile network to get started. And so that, you had something that was more expensive, it didn't work nearly as well, but at some point it took off, and then then it became a big challenge to make sure the network worked on that. We are starting to see that in cable TV as well, where they created cable TV and then added internet on later, and it kind of clicked along, and now you have Netflix, which is using 50+% internet bandwidth in major cities at night. So here's that context. So in the case of the cable companies, they're now having to figure out how to meet that network challenge that is created by that situation. So now let's look at what are consumers doing in the energy space or inside of the home space that has kind of an analogous situation, and it's solar. It's kind of like mobile phones where it's been clicking along and just kind of this like low, slightly increasing level. And if you go to California in particular, but Arizona, New Jersey, Hawaii, suddenly the people that operate the networks are going, oh man, how in the world are we going to deal with this? And so first off, there doesn't need to be some grand design on solar. Consumers are starting to decide they want it. And that creates a whole range of opportunities and risks. Batteries, like Jamey said, it's kind of hard to imagine how an electric utility system of the world as we know it can survive in terms of a reliability if you have all this intermittent generation constantly coming on, particularly in the early afternoon when people are frequently not home. So batteries, control bridges or switches that can actually manage that situation of adding a battery with the grid and with solar panels, maybe with a gas generator. So there's that whole mix of software and hardware that's driven by what consumers are doing with solar.
Hearing a lot about solar. And Michael?
Yeah, I guess I can continue that trend. I can play off of what Brewster was talking about in terms of the ability of solar to sell to a consumer directly. That's what's so exciting about it compared to other, at least what I get most excited about, relative to other renewable energy technologies, is you have that opportunity to be B2B, B2C, even B2G. So that provides different business opportunities. So what we're most excited about, especially as we look at investment trends, is this confluence of IT and energy. I believe they're calling it clean web in the Silicon Valley. But clean web as it applies to solar, and particularly soft costs. We look at soft costs in the just to give you some numbers, in the residential space, it's about 64% of the overall cost stack up. So, we did about 6.2 gigawatts of solar in 2014. So even at $1 per watt, which is, highly idealistic, you're looking at upwards of a $3 billion market in the soft cost space in just 2014 in the US alone. So what we need to do is figure out programs which we can incentivize new entrants to the space, people who haven't traditionally maybe applied to the Department of Energy solar funding opportunities. So that's the essence of why we started the Sunshot Catalyst, which is what the program is called, because we're trying to catalyze that innovation. And we do that through crowdsourcing, which is probably the other part that we're most excited about. We realized that starting this process, you need a rigorous problem solution fit. Then you talk about this product market fit, because it comes after. So we source the problems and the pain points and the wish list of the industry. And we do that through a platform. You can check it out at catalyst.energy.gov. We're going to launch another round of this in May 14th and thereafter. And once we get those problem statements, we basically look for solutions through a video pitch. So you just respond to one of these problem statements. If you think you can solve it with software, data, or automation, you just submit that video pitch, and then we decide to maybe provide some initial prototype funding, and then funding at later stages of your development. So we're definitely bullish on a soft cost, clean web, and really excited to be here to kind of let everybody know.
Great. And Jonathan, what are you seeing?
Yeah, I come back from a background with an electric utility, and so from that perspective, I see a lot of opportunity in companies and technologies that kind of facilitate how the electric grid is going to work in the future. Traditionally, the way the system has been set up is you have these large, centrally located power plants, and it's a one-way flow of electrons to customers. But what I think the future is going to be is increasingly it's going to be a two-way, back and forth. And so I think there's a lot of opportunity in technologies and software, especially, and hardware that can manage that two-way flow of electrons. The utilities are almost, they're going to have to adjust to that. I mean, clean tech investing in the past 10 years has gotten kind of a bad rap. There are a lot of bad funds that didn't work out. But I think going forward, There's a lot of opportunity in technologies and software especially that don't require those high upfront capital investments and long lead times. So for example, one of the companies we invested in the UK is a company that has set up basically a platform, a software as a service platform that manages the flow of energy and capacity between distributed generation assets, storage assets, and end users. And they're doing that in the UK kind of on a microgrid basis right now, but I think it's things like that you can scale up that will facilitate that two-way flow. That really I see the opportunity with the electric grid.
Yeah, I mean, it seems like there are a lot of different pieces and components out there, and how do you start to bring those together and actually get them to work together? There's a lot of opportunity there. And with software as a service, that's something that I've seen within the utility industry where it starts making it much more affordable for smaller companies to be able to take on some of these more advanced technologies where they may not have been able to pay a lot of money up front to get software installed, using these other providers to provide that technology at a lower cost for them, has definitely been helpful. Okay, so we've talked a little bit about some of the topics, some of the areas of interest. And I wanted to talk a little bit about some of the funding opportunities that are out there. How are you seeing them really change, or are they changing? So just a little bit of discussion around that would be great. And I'll pick on Brewster to start with that.
Well, so the Sunshot program on the solar side has been huge. It's the biggest game in town about driving innovation and new company creation. And then on the water side, where we're starting to do some consumer research as well, PACE is actually in Texas at least. It authorizes water. There's about to be a lot of money spent on water. A lot of the competencies around metering and measurement and verification that have emerged through smart grid, those apply on water as well. And there's in the market opportunities that are being driven by combinations of aggressive government funding to address huge water supply shortages. If you go from California and draw a line all the way across the United States to North Georgia, everybody south of that except for Louisiana and maybe parts of Alabama and Mississippi, everyone else is running out of water in a dire situation that is both drought and population growth driven. So there is kind of an existential risk that has to be addressed. And so what you see is a lot of new funding being put into that from measurement devices, but also new like desal package, reverse osmosis, new software, and advanced metering.
And Michael, you talked a little bit about it, but you want to talk?
Yeah, I'd be happy to kind of go through it a little bit further. I think just at a high level, at least what I'm trying to push, and in what is happening in some pockets of the federal government is our funding opportunities are trying to become more agile and maybe earlier in the innovation cycle. I think we've heard about the valley of death maybe. There's something that happens earlier. It's called the dip of death, I guess. It's this area where I have an idea. I need some very small amount of capital to build some prototypes so then I can attract further investment. So that's really where we're trying to come in at that level. Of the 17 teams in this round's cohort, about 25% are currently employed by another employer right now. So they're that early, kind of 1 foot in the entrepreneurship game and 1 foot out. But basically, we start with this problem solution fit, and then based on your video pitch, we provide up to $25,000 of software development capital. We partner with a company called Aperio, which then also has relationships with a company called Topcoder, which does crowdsourced software development. And it's really exciting. What it does is it has a community of 700,000 plus developers, and they discretize your software development into a series of sequential waterfall contests. So people from this community compete to win each one of these contests, and they advance your product from maybe an early wireframe to a full-fledged prototype that's hooked up to some back end. So right now we have these 17 folks in this kind of product development cycle, and altogether it's going to be done in 90 days. So in 90 days they're going to have a minimum viable product complete, and they're going to demonstrate this in San Francisco on May 14th. We're going to have our demo day. It will be open to the public. So you'll get to see what these folks have built. We'll have a panel of judges. We'll provide some feedback. And at that point, we'll select 5 to receive a $30,000 investment and then go through well, it's not an investment. There's no equity taken. It's a prize. And 6 months later, we'll reevaluate these 5 companies on their progress, and they have the opportunity to receive an additional $70,000 prize.
Wow.
So the total prize purse is $500,000 in cash and $500,000 in software development services. So we're on path to be on schedule for demo day. We're looking forward to launching the second round. So I probably get calls twice a week from other folks in the government trying to figure out how to use prize authority. It's been said that our program is the fastest across government. It's difficult to measure exactly how we stack up or benchmark, but I think we are trying to change that image for government funding opportunities.
Yeah, and really getting the community involved. That's
Right.
great. And Jonathan?
Yeah, so I'll talk specifically about PACE, or Property Assessed Clean Energy. So some of you might be familiar with the concept, but PACE is essentially a mechanism for financing energy efficiency upgrades, renewable energy systems, and in Texas, water conservation systems as well. And what PACE allows you to do is to finance that through an assessment on your property. It's been around for about 10 years or so in other states in the country, but in Texas is just now coming. And essentially the way it works is you would put together some type of project which reduced your energy load or your water load, and you would find a lender that would loan you the capital up front, and you would pay for that through an assessment on the property. Some of the advantages to that are that the assessment, it can never be accelerated, so you won't have a lender ever call that loan early. And it transfers with the property. So if you were to put in something that would take 15 years to pay for itself, but you sold the property 5 years later, the assessment would just transfer to the new owner, so you wouldn't be over-investing in those projects. I think that PACE has great potential here in Texas for helping to finance essentially building upgrades that would take a long time to pay back, and you normally, under a normal financing mechanism, you wouldn't be able to get financing for that. And PACE is a really valuable tool for that. So just to be clear, so my organization is a nonprofit, so I don't have really a dog in the fight on any particular technology. We are just administering it on behalf of counties in Texas, where if you put together a package of either one improvement or a set of improvements that can that can save you more money than they cost over the life of the assessment that you want, and that could be 20 years even, you can get a PACE financed loan.
So what would be some examples? I know you said you didn't advocate for any specific technology, but what would be some things that homeowners would be looking at?
Yeah, so to be clear, in Texas right now, it's not applicable to residential, so not homeowners yet. Right now it's just commercial and industrial. That could be any measure that reduces your energy load or your water load. So that could be something as simple as insulation or lighting or a boiler replacement, HVAC upgrades. It could cover solar systems, water efficiency. One of the things that I think, one thing that you could use PACE for, I think that should be, if you have a new technology that maybe is tough economically to make a case for right now, is you can actually put together a package of these improvements. You could tag some, a high-tech, maybe a fuel cell system or something on top of a lighting improvement that, would almost, I hate to say subsidize, but kind of would help cover up the cost. All we're looking at is the total savings versus the total cost. So you're able to put together a package of really any technology that helps your energy efficiency or your water.
Okay, all right. And Jamey, what are you seeing?
I think from the oil and gas side of things, I think the big thing that we're seeing in terms of a market model shift is an increase in interest and willingness to partner. It's already industry that partners heavily to defer risk. But when you have the current macroeconomic situation, I think it definitely is a situation where we're seeing more interest in partnering to develop technologies and more interest in licensing, and also more opportunities for smaller technology companies to make a pitch to be acquired versus having large internal R&D efforts. We typically have a bunch of those large internal R&D efforts, but in this particular climate, that creates a lot of interesting opportunities to look at purchasing technology instead.
And when do you really see corporations willing to go outside and look at independent companies? I mean, what is sort of the tipping point to?
Yeah, I think there are really two key factors. One is when you start looking at what are the costs of your internal R&D versus the costs of that external technology. Mm-hmm. So I think that's a big tipping point for you. But the other key factor that plays into and ties into that is your speed to market. So you have, you have the perennial problem of technological obsolescence, and that's often driven much more fast by, or much faster by, the fact that competitors come into the market. So it's not even that your technology is obsolete so much as it is, it's now just commoditized. So I think there's a big driver to look at going externally and to buying technology if it buys you a further step down the development chain and an opportunity to get into the technology faster and really earn your return on it. Mm-hmm.
So we've talked a little bit about the role of government within funding and corporations. And Brewster, do you want to take a moment to talk about universities? I mean, what could they be doing better, or what are they doing right now to really help with the commercialization of IP?
Yeah, it's been very educational to work a lot with universities and start to see the patterns of what actually makes sense from a commercialization standpoint versus what is, it's just not set up to happen. So one great example of how university commercialization has been a very successful model is the extension service model, which comes out of agriculture. So you think about it, it's very clear metrics on what is successful, right? Is that agricultural researchers have to develop stuff that has to be practical because the metric is, did it create more safe food, basically, at a real high level. And so the extension service was the university-based institute that connected practitioners, the end users, the farmers and ranchers, and the seed companies and others with university researchers to help the university researchers understand what was needed to actually be researched. And then once that was developed, help educate the practitioners in the real world of, hey, here are the new innovations that are out there that you can license the IP on or test out in the real world or adopt. So what does that look like in energy and water? Well, first off, big chunks of a university are just not, what they do is not well set up for commercialization. The obvious ones are like a history department or an English or something like that. But even math is not really well set up. But a lot of engineering is. And then so I think an important part of what we've seen as a value we can help provide is that right now, university engineering students and faculty are very unfamiliar with the kinds of data that can actually help guide good research and commercialization on the energy and water side. So one of the things that we help do is actually provide what's never been available before in any kind of high resolution format, which is good data and actual people. Like, we were created by UT because it was essentially illegal for them to go into people's living rooms and test stuff out. Well, that's a huge barrier, but so we're able to do that so that they're actually able to get into people's living rooms, universities around the world now, and actually get real experience. So I think that one of the things is just to understand that grad students are typically going to be better off, for commercialization efforts, because a lot of them are already kind of in the mindset of, I'm looking for what I'm going to do after I finish. Grad students in engineering in particular, because they bring some technical skills to the table. You know, in addition to agricultural, pharmaceuticals is another area that's been successful. But I think engineering fits that model with grad students. Faculty, it's going to be a little more hit or miss because the faculty's reward metrics are how they get published and they make tenure. And so a lot of them very fairly aren't interested in going to try to create a company because they've got their plate full already. And, but some are interested. So I think don't be naive in what to expect from a university, and particularly the faculty member side. But you'll find guys like Michael Weber who are crazy entrepreneurial and want to go create companies and change the world that way, in addition to teaching. But your grad students in the engineering disciplines are, I think, a good segue of not just future talent, but the people who are ambitious enough to go create companies.
Excellent.
If I could just give a specific example. One of the 17 teams we're backing is a professor combined with a tech spin-out commercialization entity at Texas A&M. And I guess I can't speak on all the commercialization strategies there are at across academia, but this one seems to be particularly unique in the fact that Texas A&M has set up a new ventures wing where they kind of take somewhat of a portfolio approach where one person has like a set of ideas that they're kind of incubating. So the team is a professor and this kind of portfolio manager at Texas A&M, and they're able to recruit folks, mostly MBA students, to kind of help with the spin out. So the professor is developing the technology. In this case, it's a customer acquisition platform for solar. Basically, you take a photo of your roof, you answer just a few inputs, and then you get like some bids, and a solar installer will reach out to you. But yeah, I mean, basically that relationship has worked quite well, and they're doing very well in the program right now.
Well, that's great. So, I mean, I feel like we've talked about a lot of different pieces from the university, the government perspective, private industry. I mean, are there opportunities to improve some of the collaboration in those areas? And, where can that be improved? So if Jonathan, if you want to take a moment to talk about that. You've done the university side as well as
the venture fund I worked for was actually wholly owned by the University of Cambridge. So, we were very much aligned with the university's mission. And I think from that perspective, a lot of times the companies we dealt with, there is a misalignment. Companies have are profit-centered, right? Whereas the university's mission is, at least at Cambridge, and we took it very seriously, that we were there for the benefit of society and to do research and to disseminate that research. And if commercializing was, the best way that we picked out to get that research out, then that's what we would do. But the university doesn't exist solely to commercialize technologies and to make money off of them. Having said that, I think sometimes in the university we tended to overvalue the IP and just the idea portion of that. Mm-hmm. In any new technology, the real value, the idea and the IP can be valuable, but the real value is in the execution of that. And that is really where I think industries can help universities to do that, because like you mentioned, dealing with a lot of professors, they're interested in the research, but maybe not so much in the nuts and bolts of putting together a business. And it's facilitating kind of how do you take that idea and actually execute it that really is difficult. And a lot of my job there was in putting together those teams, and you find a lot of, or at least I found a lot of resources with younger students, with graduate students that were very ambitious and that had the support of a major professor who maybe didn't want to take on a full-time role with a university spin-out, but had a team of research staff that would love to do that once their postdoc or their PhD was over.
What are you seeing around some of the collaboration opportunities?
Well, I think the thing that we would have the most interest in and like to see the most is the biggest difference, I think, between alternative energy companies and the oil and gas sector is in the oil and gas sector we have a lot of technology that we don't use anymore, but that probably has really fantastic applications in other industries. But the difficulty with that is figuring out what the application is and how to utilize that technology. So I think one of the things that we would love to be able to do with universities is to figure out ways to come up with those joint ventures where we can take the technology that we have that probably we don't need any more in our core business, but we've got a lot of the tech, and contribute that to joint ventures that help commercialize that tech for other purposes and for other industries.
Yeah, and I think on that point, hearing from both of y'all, that the sweet spot on commercialization, on one kind of commercialization, is going to be in an industry that its processes and business models are well developed. Mm-hmm. So that's why, for example, pharmaceuticals has been an area where universities dominate on the development of new breakthroughs. And that's because there is a well understood market structure of, what are the problems to be solved for, what are the market mechanisms by which new medicines are tested, or medical devices are developed. What do they need to do? What are the metrics of success, and all that? So that works well. Oil and gas is another one, right? There is a well-developed, successful market structure, so that if an engineering faculty member or student develops something that improves one of these well-understood processes, there's a pretty clear understanding of what would be a market value for that innovation. But you get into what is happening with solar right now, and there's a lot of business model churn right now for starters. Like, is it leasing? Is it ownership? And then what happens if you get to the Hawaii situation where you have more rooftop solar installations than the distribution systems can handle? Well, what then? How does the evolution of improved natural gas generators impact that? What are the intermediary devices, like some sort of bridge device that can manage these various flows of energy, and who gets paid for that? What's the value? There's a lot of unknowns, and so there's a ton of opportunity in that, but that is a ton of opportunity that is on a value chain that is in flux, which makes it very difficult for universities to apply that precision model they can apply in oil and gas or pharmaceuticals into this industry where it's unclear what portion of a value chain they would plug into.
So how do you start to help better define that? What can happen to really better define that process within solar and renewable energies and things like that?
Yeah, I think part is that is an area, for example, that is a sweet spot for government, because government has to have the whole lay of the land, and not just their part of the widget. And not to mention, particularly in an industry where there is going to be a significant public component in the mix, and so distribution systems, even in a competitive market like Texas, are highly regulated. Government in some degree, with a high degree of government oversight of monopoly providers. So there's a core part of the value chain in energy, electricity, that has a heavy government involvement. And so that's where these guys are, I think, well positioned to have the broadest lens on what are the current gaps, and my perspective in government, you have to know everything that's going on and know everybody, and that's pretty. When an industry gets real well developed, that's not nearly as important. Mm-hmm. There doesn't need to be like an eyes and ears for government innovation in oil and gas, because that industry's got it figured out and doesn't. Everybody knows if I create this value chain improvement, then there's a market for it. But that's so unclear that having someone who has the big picture is really valuable.
Yep. Right now, kind of our strategy has been to incentivize standardization through scale. So you can see we're definitely dispersing the capital across a lot of different startups, right? And I can give a quick example in terms of data, right? Data standards are all over the place. We're not actually quite certain what data fields are important for various applications. One of them being performance data. Do you want performance data, which is very important for financial securitization of solar assets? Do you want O&M data? Do you want data that makes customer acquisition easier, right? You want all of it, right? But you want certain companies delivering certain data to certain customers. So one of the companies that we support or backing right now is Utility API. They just make it frictionless to get utility solar data for solar customers. And they do this through creating kind of an open API or API adapters. If you're not familiar with that, it's application programming interface. It's something like a green button, but having multiple utility providers able to use this. So right now they're doing very well. They've signed up a few utilities as customers. So, something like that at scale, presents the opportunity to kind of standardize the acquisition of this data. And then that in turn helps adoption and driving down soft costs.
Let me grab my microphone here, and I will be running around with this. Yeah.
Hi, I'm Dan Patton. I'm retired. I came out of the semiconductor industry. And when I started looking at these grids and stuff, holy crap, it's 10 orders of magnitude more complex than the semiconductor industry. And I had the fortune.
That's scary.
It's more than scary.
Yeah.
Xanax is good. One of the first things came to mind, I was in Semitech, so I came out of Motorola Research and I went into the semiconductor industry, and I spent 2 years at Semitech as an assignee. And it took about 2 years just to figure out who you should talk to and what was really going on. We had something called the Advanced Test Development Center. And I was the interface to DARPA. They were doing the funding of it. It was kind of neat in that you could actually get access to equipment and be able to run it. One of the problems with the university handoff is you're a slave to your machine because you got it published, and the only good thesis is a finished thesis. And so that's your focus. But you've got a lot of this distributed equipment all over the place. And so you got the theoretical people, you got the battery people. We actually had battery people on silicon back in those days. Didn't work out too well. But you had the ability to have test facilities. You had people, their full job was to create that test facility, kind of the old idea of the machine shops in the 60s and 70s. And you were able to try stuff out. How in the hell do you get management to be able to learn what a smart grid is unless you got a smart grid to go out and ride? I can't write memos on how to ride a bicycle. You just got to get on the bicycle and you got to ride it. And there's a lot of talent in the U.S., the national labs, Livermore and Sandia and all that. But there isn't a collaboration point where you can all get together and you can go out and you can try and ride that bicycle. And without that institutional memory of riding the bicycle, innovation is going to be just really, really slow. And if I were going to do innovation right now, I'd go to the Ivory Coast, I'd go to Uganda, I'd go to those places. They put a generator out there and a flow battery, and a whole town moves. People move to where the energy is. And the one thing, at Motorola, we tried for years to get a $35 world phone. The phone wasn't the issue. A phone is a mobile energy device. And the biggest thing, when I went to Africa, I slept on a dirt floor. It's dark from 7 o'clock p.m. to 7 a.m. You're 1 degree off the equator, and it's that way year round. So until you get to be able to recognize that, the greatest thing about Semitech is we had grad students coming through all the time. You stick them out in the fab, and after 48 hours, holy crap, that stuff in the textbook's worthless. And so that's the real industry, the real issue. And so there's no difference between all of the advanced connected machines in a fab and a solar array and distribution grids. But how do you experience that? I mean, we're lucky here in Texas. We got ERCOT, so some of that expertise and knowledge gets out. But how do you transfer that to the people who are coming up with the decisions of what kind of software to make?
Any comments on that?
That's kind of what we do. It's and in particular, we've taken kind of 4 or 5 years of bumps and bruises of learning what did and did not work on the electricity side and applied it to water. And so the ramp up on the water side has been really fast. But so I'll kind of explain to you how we did it on how we've done it on water as a kind of a way to show what we learned in electric, which is. If you're going to be testing new stuff out, you've got to minimize the risk of the individual entities, not to mention if the individual entities, the utilities in particular, are all doing it themselves, then it's going to, the ability to develop a common set of best practices is very stunted, or it becomes an impediment to it. So that's the consortium model that was developed was the way to kind of overcome that, right? You have companies that are all working on parts of the value chain work together, ride the bicycle as opposed to writing the memos on it. And so, you know, we've learned is create as few barriers to entry and reduce risk as much as possible for the entities in the consortium and try it out in the real world. Have a lab testing component of it, but have it developed in the real world and that becomes a safe way, by the way, for industry to interact with these companies. So if you take a utility, a lot of times, particularly if they're public utilities, which on the water side, 98+% of them seem to be, is they're going to have very strict procurement rules. They can't even test out meters without a procurement process, but a consortium can test out meters, can test out 5 or 6 in the field in different homes at the same time. And then, you know, in our case, 25+ utilities can see the results of all these devices in almost real time. And so you can radically accelerate the real world testing and identification of what works and get it disseminated quickly. So I think that consortium model that you come from Symatech is a very useful model, particularly given the market structure in electric, gas, and water utilities.
I'm Matt Smith with San Diego Gas and Electric, and one of the challenges that we come across right now is with the development of all these cloud-based devices, Internet of Things, smart home, smart thermostats, is that these products are designed such that they can be updated and they are learning behavior, they're changing their algorithms to best suit the home that they're in theoretically. And so from a utility perspective, you were just discussing some of the things that at least a regulated utility, you have to deal with all of these 3 to 5 year processes that you're stating that this product that I'm putting into this home, that I'm giving a rebate for or whatever, is going to give these savings for this amount of time. And the whole paradigm of how these products are going into people's houses is that they're supposed to be constantly updating and changing and adapting. And so what do you see as a path forward for a regulated body to support this? Like, I work in emerging technologies. We think these things are really valuable, but how do you see like a rigid structure still supporting this dynamic environment? And particularly when you guys are talking about solar, with the energy moving back and forth, that's going to require a lot of software that's going to be adaptive. And how is it that a utility is going to be able to say, all right, this is the framework that we want you to use, but then you're still going to have things that are dynamically adjusting and fitting into your whatever model that the utility is using? I just thoughts from you guys. I know you're not going to necessarily have an answer for it, but curious what you think.
Great.
Yeah, I mean, I guess that's the $1 million question, right? How do we balance creativity with regulation? I think what we kind of encourage folks who pass through the Catalyst program to do is just start small, start local, start with a pilot, right, and then build from there. If you look at, I hate to make analogies to Uber, but I mean, they started in San Francisco, scaled slowly, you know, basically learning the regulations of each authority having jurisdiction in you know, your case. But I would also say maybe not investor-owned utility first as well. I would say start at the co-op level, the muni level, kind of find a model that works so that you can build that confidence that you can meet any said regulations that are specified, right? Because that's the biggest risk on your part is can I trust this entity which I'm buying services from to meet the regulations which I specify? I'd say also on the other side, utility tools, I feel like, shape thinking. So if there was a way which we could change some of the tools that utilities use, then when a startup maybe approaches a utility with something that doesn't necessarily look and feel like what is used every day, it's a little bit more palpable, a little bit easier to make that leap. So I feel like there's stuff that can be done on both sides. But those are just kind of my thoughts on where it could go.
there's a model emerging in the IT world, which was, had a lot of similar dynamics to what utilities have to evaluate. So the IT manager in big companies, they'd all get BlackBerries. And then they'd all be set up under a common protocol. They all had to be managed, and so any software update had to apply to the entire company. And in the last 4 years, there's been a very rapid shift to a bring your own device model. And in that model, the IT manager just says here's what this device needs to be able to do to port into our network. And then if your device can manage that, then we're not going to get too hung up on which it is, but we're not going to manage your acquisition of the device. It just has to be able to port into our network. And so I think that may be a model that would work. We're testing that out on the water side, saying, okay, what if there were a meter that did something that the customer considered sufficiently valuable for the customer that the customer would throw in some cash for it, such as a meter that also helped you detect leaks at your house, which your home insurer might be interested in. Well, so at that point, you're like, well, hey, maybe I'll buy my own meter. Well, then you just say, okay, what are the performance specifications that the utility needs to make sure this device meets? And if it meets it, great. And so it allows for a little bit smoother process. That's clearly easier said than done, but I think that there is probably some metaphor like that will emerge. And if it does, Matt, it's going to be at SDG&E because y'all are among the most adventurous of the utilities, and your customers are way more adventurous than everybody else. So you're dealing with more solar and more electric cars, for example, than anyone else.
Good morning. I'm Brenda Phillips with Sane Engineering Associates. We're an energy consulting company. And my question is for the PACE financing. I have two questions. The first, when it's 100% financed, does that include all of the consultant and design fees? And then second, are private universities considered commercial so that they could go after funding as well?
Okay, so in answer to your first question, yes, you can roll all of those consulting and engineering fees into the PACE loan. There's quite a lot of things that you can actually roll into the final assessment. So you can roll your, essentially your closing costs, our admin costs can get rolled into there. Any of the engineering or consulting fees, and even ancillary equipment. So if you wanted to replace the lights in your parking lot, and you can include the new poles for that. Anything that's kind of ancillary to that installation can get rolled into the PACE loan. Your other question was, can a private university use PACE? So right now in Texas, governments are excluded, but if it was a privately owned university, that would be okay. And all these rules for PACE right now, we're just trying to get it established here in Texas. Going forward, there might be some adjustments as far as who specifically are eligible, but for right now, government properties are prohibited, but privately owned are not.
Well, that's all the time that we have for this morning. A lot of great conversation, a lot of great questions from the audience. Now we go into a 30-minute break. We'll be meeting back upstairs at 10 o'clock for the next keynote. So please join me in thanking our panelists. They did a wonderful job.